Now, for our next session, we're excited to welcome Mr. David Rosenberg, who's the CEO of AeroFarms, who will be giving us a talk on transforming agriculture from around the world. Mr. Rosenberg, the stage is yours.
Hi, everybody. I'm David Rosenberg, co-founder, CEO of AeroFarms, and here, building on what we just heard, I'm going to share about how digital transformation impacts food and agriculture. So, a bunch of stuff to go through. First, I'm going to go fast. We know a lot of the big problems from an environmental standpoint. There's population growth, which leads to stresses on our natural resources. We read about tremendous droughts. We read about flooding. Here, this is an image of flood irrigation, which often is the way we farm. There's a lot of industrial agriculture brings a lot of clumsiness in food and food production. And here, this is crop dusting. So there's not a lot of sophistication in just dumping and spraying pesticides, herbicides, fungicides. And we over-fertilize, which leads to river runoff that leads to dead zones and algae blooms and dead zones and dead fish. So we also have a lot of long-haul production, a lot of centralized manufacturing that then leads to sending food to very far-away places, and it leads to a tremendous amount of food waste. So a lot of problems. So here are some of the solutions and some of the enablers. So there are a lot of enablers from data analytics, computing power, microchips, artificial intelligence, robotics, genetics, synthetic biology that's changing the way we grow plants and also produce food. Here, I'm going to give three quick examples. One, the company I lead every day, which is AeroFarms. I'm also lead at the board level, chairman of the board of Every, which we make proteins. We make chicken proteins, not out of chickens, but through precision fermentation, and also Aspire, where we make proteins from insects, specifically crickets. So first, AeroFarms, and I'm going to show you a video, and this is a facility of ours in Virginia. We just built a facility in Abu Dhabi. You're going to see a lot of robotics, and there's a lot of networking here. We actually work with some of the partners in the room, with Dell on our edge computing, with Microsoft on Azure, with Google. That was a plant being grown on growth media. Instead of soil, we use cloth. That's a seeded, germinated tray that goes to a container where the plumbing is, and then that's germinated, meaning the seed opens up, and this goes right through automation to these towers. And here we serve to Whole Foods all over the United States. We're in about 300 Walmarts. We're in a bunch of retailers all over the U.S. These are seeded and grown plants that go into these 48 towers. These towers are taller than the ceiling. They're 50 feet high. This ceiling's probably like 40 feet high, just to give you a sense of context. And here the lights are programmed to optimize photosynthesis. So plants don't need sun, they need spectrum. So what spectrum intensity frequency optimizes plant growth? And here, all this is connected to from our MES to our user interface to our SCADA, our industrial controls, to our PLCs, program logic controls that connect sensors, valves, pumps, lights, fans, and so forth to optimize plant growth. If you think of what makes a plant great, it's either the temperature and the environment has a lot of contributing factors. It's not just the genetics, like what seed you grow. In about 36 seconds, it goes down through loading and unloading and goes right to harvesting and then right out to the door. And here there's, I'm going to, in the interest of time, go fast, but there's a lot of robotics and digitization that optimize plant growth. And it doesn't just about growing a plant for yield, it's about optimizing taste, texture, nutritional density, all these different features. So a lot of automation and robotics after this. And if people are interested afterwards, happy to give you more. I also brought samples of our facility in Abu Dhabi. I have parsley, mint, and peppers here that were just took out of one of our facilities yesterday. And this just goes right to retailers. This is packaging and so forth, and it goes right to automation in cleaning. So it's a closed loop system, and this is all with edge effect computing and the data science. And here we grow. One other point to add: we have 80 crop cycles a year on this facility. This facility I'm showing you is in Virginia. So in the field there'd be 5. In the field, that's 5 learnings with variability that's unknown. So the weather does what the weather does. Here, 80 crop turns versus 5, where we get to isolate a variable, test an assumption, and really from a scientific exploration standpoint, understand what drives plant growth. So I would argue that we're moving to really understand the mysteries of plant biology and selling again to places all over the country. Here, again, this is enabled by a lot of digitization, a lot of advanced technology. And it's not just the mechanical side, it's the biological, it's the genetic, the data science, the operations, the environment. It all comes together to grow plants. This is an example of one of our partnerships with Bell Labs, Nokia Bell Labs. So here we worked on the imaging. You get a lot of information from an image. You could quickly understand the size, the height, the stem length, the petiole length, the ratio of that, curvature, spotting, ripping, discoloration. It all means something. And from that, we could grow plants differently, give the plants different inputs. And there are drones that fly around to capture this sort of data. Now, what does it mean from a plant growth? So some of you are familiar with Net Promoter Score. So Net Promoter Score, one's like a likelihood of telling your friends to buy a product. So here, we're able to grow plants, taking the same seed as these other players, where conventional Net Promoter Score is 27, others in organics are 35, or in greenhouses or other vertical farms, we get 61. And I would argue it's from the data analytics of just understanding how to grow plants, how to optimize bitterness, sweetness, pepperiness, the crunch of a plant, all of these features, it's all driven by the digitization. And then we get to go from centralized manufacturing to distributed manufacturing. From an environmental standpoint, we check almost every box. We grow using less than 5% of the water typically used to grow a plant. So how do you take water, take out algae through filtration? How do you take dehumidified water and put it right back into closed loop systems? And this is an image of our facility in Abu Dhabi that we just opened. And we're going from leafy greens to berries to we're growing cocoa for Cargill. We're growing hops for AB InBev. These are some hops that went into a beer called Goose Island, their IPA. So there's tons of challenges in the agriculture space where systems like this could have big impact. We've certainly won a lot of awards, recognition from our leadership on the environmental side. Another quick example, so that's AeroFarms. Here, Aspire, cricket protein. So now imagine what I just showed you in vertical farming using other digitization systems to grow a cricket. So crickets increase their mass 600-fold in 30 days. I don't know another way to produce proteins as efficiently as a cricket. From a human consumption standpoint, it's hard from an adoption standpoint to get people to get over the ick factor, but we are applying. So we just built this facility. This is about a $100 million facility. And in that big area, that's crickets, level upon level of growing crickets in this whole area. And using, again, a lot of digitization, a lot of robotics to process the crickets. That's a nice way of saying we mush them up and powderize it and sell it to dog food. And then the last example is Evry. So here we make chickens. We make eggs, but not through chickens, but through precision fermentation. And here, there's been tremendous advancements in sequencing the genome and how do we improve what's called our titers, or basically chemically reproduce the same chemical aspects of an egg, but through precision fermentation. Meaning if you're allergic to eggs, don't eat this product because you'd have the same allergic reactions, but it's chemically the same as egg whites. And we use this for different applications as a protein soluble in water and in baking. When one uses eggs in baking, they either use it for congeniality, so congealing purposes, for foaming purposes, for gelatinous purposes, and we're able to develop those qualities in products like whether it's an omelet or baking, things of that nature. So a lot going on. I'm happy to share just in conclusion that I took my daughter here. I live in New Jersey, but I took my daughter here to the museum, and on the second floor, there's a nice feature of AeroFarms. So we saw me giving a presentation there, which was a fun feature to be in the Museum of the Future. It's entitled Tomorrow Today. But anyway, happy to collaborate more. We're very proud of our presence here in Abu Dhabi. I'll share that I'm excited about the region because as an entrepreneur, as an innovator, one wants to go where there are early adopters and there's a lot of boldness. Just look at this beautiful museum to a lot of boldness to do hard things. And that's what the world needs. So anyway, thank you very much. A pleasure being with you.